Red lights on skyscrapers, towers, and turrets are also known as aviation obstruction lights. They are important safety features that are used to prevent collisions between aircraft and high-rise structures. Aircraft obstruction lights are critical safety devices installed on tall structures to make them visible to pilots and prevent collisions. They are an integral part of aviation safety and urban planning. History of aircraft obstruction lights. The concept of marking tall structures originated in the early days of aviation in the 1920s and 30s, as pilots needed to avoid hazards in poor visibility conditions. Initially, simple incandescent lamps were used. During the World War II era, with the development of aviation and the construction of taller structures such as radio masts, obstruction lights became mandatory in many areas. Modernization occurred in the 1950s to 1970s with the development of brighter, more energy-efficient lighting such as xenon and fluorescent lamps, which improved visibility and reliability. Currently, LED-based obstruction lights dominate, offering energy efficiency, durability, and reduced maintenance. Intelligent systems that adjust brightness according to ambient lighting conditions are now common. Typically, these lights are installed on a variety of tall structures, such as skyscrapers, communication towers, high-rise power lines, and wind turbines. Their installation on all such objects is a mandatory requirement. Aviation obstacle lights are generally designed to be easily visible to aircraft pilots. They generally emit a steady red light or a bright flash that can be seen for miles around. This alerts pilots to the presence of a high-altitude object and allows them to adjust their course accordingly. Basic rules and regulations. The rules vary by country, but generally follow the standards set by the International Civil Aviation Organization, ICAO, and the Federal Aviation Administration, FAA. Height thresholds. The FAA requires obstruction lighting for structures over 200 feet, 61 meters, above ground level. In some cases, structures below this height near airports or on airways also require markings. Light types and colors. White lights, strobes, used day and night, especially for tall structures such as communication towers. Red lights, typically used at night for better visibility without glare. Two light systems, red at night and white during the day, are also common. Flash rate. Strobe lights should flash at specific intervals, e.g., 20 to 60 flashes per minute. Placement. Lights should be placed at equal distances along the structure to ensure visibility from all sides. The reason for using red lights is that the human eye perceives red at night, and red has a longer wave than other colors, which makes it more noticeable at long distances. In addition, red does not impair pilots' vision at night as much as other colors, allowing them to maintain visual acuity. The use of aviation obstruction lights is of great importance. Without them, tall structures would not be visible to aircraft pilots. This would increase the number of accidents and incidents. This is especially important for structures such as communication towers or power lines, which are usually located in remote and sparsely populated areas. The light from aircraft obstruction lights is also used on wind turbines, which are installed in large numbers in uninhabited areas. Accidents and incidents. Despite the rules, obstruction lights have not always prevented accidents. Milwaukee TV tower crash, 1971. A small plane collided with a 2,000-foot TV tower due to poor visibility and possible malfunction of the obstruction lights. Helicopter incidents. Several helicopter accidents have occurred due to unmarked or poorly lit structures, especially in rural areas. Urban hazards. Obstruction lights that fail due to power outages or maintenance issues have caused accidents in densely populated urban areas. Interesting facts. Energy efficiency. Modern LED obstruction lights use up to 90% less energy than traditional incandescent bulbs. International standards. Different countries use slightly different intensities and colors of light, but ICAO and FAA standards aim to harmonize practices worldwide. Bird-friendly designs. Research has led to changes in lighting design to minimize confusion and collisions with migratory birds, such as using flashing red lights instead of steady ones. Dual lighting systems. To save energy and improve safety, dual systems automatically switch between white, day, and red, night lighting, depending on environmental conditions. Automation. Modern systems are often remotely monitored to ensure continuous operation, with alerts in case of malfunctions. In conclusion, I would like to say that aviation obstruction light systems are an important element of modern infrastructure, which makes a huge contribution to the safety of aircraft movement, helping to reduce accidents and comply with international aviation standards. They also have a positive impact and interaction on nature and the environment.